My name is Joe Grand. It's cool to see, I know half of you, so to the other half, hi. I'm a hardware hacker. I spend a lot of time sort of exploring electronics and finding vulnerabilities and teaching people about how to find vulnerabilities in things. This is a super exciting talk because it's something that we don't really get to see a lot in the wild. And this is sort of an adventure of reverse engineering a hardware implant inside of a Ledger Nano X cryptocurrency wallet. So it's very, very exciting, and it's fun to sort of eat my own dog food a lot of times. I teach a lot of classes about hardware hacking, and I say these sort of things of follow this process and do these things. And this was actually a really good exercise for me to actually practice what I preach. And it was pretty cool, and it worked. So very exciting. This whole story sort of started back about 5 years ago. A guy had contacted me and said, hey, I have $2 million on a cryptocurrency wallet. Can you help me hack it? And this was right at the end of COVID. I wasn't traveling a lot yet. It was a well-written email. It didn't seem like a scam or anything like that. And I said, sure. He had a Trezor One hardware wallet. Some friends of mine at that point had already given some talks and proven that the STM32F2 inside of this device was hackable, glitchable with fault injection. And I was like, how hard would it be to just replicate their work and hack this guy's wallet and recover his funds? And it turns out it was actually pretty hard. So it took three months to figure out, finally freed the money from his device, and here he is. I hacked it live, we filmed it. YouTube video went viral. He was very excited about it. He flew all the way from New Jersey to come and watch me hack live, which if you've ever hacked live, you know the sort of stress of that. And afterwards, I'm like, I cannot believe that I did that. Having a camera crew and him watching, it's as close as a hacker can get to being a surgeon, right? When everybody's sort of relying on you. Yeah, and it wasn't until afterwards that I realized, oh wow, there's actually a lot of risk in what I was doing. But anyway, this sort of kicked off kind of this adventure of helping people recover cryptocurrency, and we've made different videos about it. And a lot of this work I'll be releasing soon based on this stuff, but this was the beginning of the journey. And I'm sort of ramping down on some of that stuff, but this particular project was not even about recovering cryptocurrency. And that's what was so interesting of something different, right? I've been doing a lot of this same work all the time. All of a sudden it's this guy contacts us not needing help, but wanting us to figure out what the heck is going on. So this initial contact with this particular person, he had basically had a Ledger Nano X, which is a cryptocurrency hardware wallet that stores recovery seeds and will do your signing. And I'll show what it looks like and explain all of that. He had one. He already had it set up, but the internal battery was dying. So he said, okay, I want to just replace the battery with another device. Piece of cake. So he lives in Thailand, ended up going to Lazada, an online sort of store in Thailand, and found the cheapest possible Ledger Nano X that he could find because he just wanted the battery. He didn't care, the condition of it or anything like that. So he ended up buying it, got the device home, opened it up, and realized, wait a second, the battery's smaller and there's something else going on. So he had just discovered this completely innocently, trying to just, replace his device. So he posted about it on Reddit. And being Reddit, of course, people are like, you're full of shit. This is not true. This doesn't happen. And he actually said he went to the police in Thailand and they're not interested. So he ended up finding me because of the cryptocurrency wallet stuff. And he said, hey, can I send this to you and you just take a look at it? And I was like, whoa, you found an actual hardware implant in the wild? Yes, of course I'm gonna do this. This is it tickles all of the hacker curiosity of how does this thing work and what is, the motivation. So this is a video that he sent me to prove, as he was opening this thing, to prove that there was something else inside. Of course, he sent me the regular speed version. So I don't know if you can see, but there is a bunch of wires connecting to that little green circuit board there. That's normally not there. The Ledger Nano X board is the black board. It does not have wires connecting to an external board. So he knew enough to say that looks different. This is not a legitimate device. This is, something's been, actually it is a legitimate device, but it's been compromised with some additional circuitry. And he noticed that the battery was smaller also, and the battery was made smaller so that hardware implant could fit in there. You can see a little antenna there, so right away it's like, okay, this is probably transmitting something. And there's some silkscreen markings on the board. I'll get into all of that, but it was very intriguing of like, what is happening? What are they doing, right? So that's the beginning of the story. But before we get too far into it, I want to talk a little bit about hardware espionage. It's something where, we trust hardware, right? We sort of buy things from distributors, we buy stuff from Amazon, whatever. How many of you, when you buy a piece of hardware, open it up before you plug it in or use it? Like maybe a couple people, right? Like it doesn't really happen. Even if you know there's a potential for compromise, you just sort of trust the stuff that you're plugging in. We shouldn't. But we do. It's sort of like, I know I should probably, patch my operating system, upgrade things, but I don't want to break anything that works, so I'll, potentially I'm vulnerable because I haven't upgraded. Hardware, same thing. We just trust it. But I would say not all hardware follows the rules. And there's a lot of different stories about hardware espionage that I'm not going to go into, but it's something that can exist from a hardware perspective, from a firmware perspective, even from, say, software that's controlling a device that maybe has some malicious functionality or some additional functionality on top of a system's regular functionality that's doing something. Every step of the product lifecycle has hands touching it that people can get access to. And there's a lot of academic work in some of these fields about how chips could be compromised with malicious functionality, or when components go to distributors, are there people that could maybe sell in counterfeit devices or manipulate devices or modify devices? So lots of different ways to go, lots of different hands touching things, which I'm not going to get into all of that. Bunny Wang gave a talk a bunch of years ago talking about this whole landscape. And it's amazing, even if you think about, we buy integrated circuits, we buy chips and put them into products. Even those could be compromised. But really, it's the stuff that happens later on in sort of the supply chain attack, if you will, that happens after the devices have been manufactured. And that's sort of what we're focusing on now. Not something where the system's been modified during manufacturing or during the process, but after the fact. So we're sort of looking on the right-hand side where components get built, or components are ordered, systems get built, they get sent to whatever distribution facility, wherever that is in the world, legitimate products, those get sold to various places. You might order something, it goes through UPS or DHL or something and goes to you. We know through some of the Snowden leaks that our government has actually intentionally compromised devices on the way to a target by basically waiting until somebody's ordering a product, intercepting it, doing something to it, packaging it, sending it on its way. So there's a lot of different places, but what's not shown in here is what we're dealing with this example. And I tried to mimic the artwork as best as I could, but it basically is somebody buying legitimate off-the-shelf product, taking it, modifying it, repackaging it, and then reselling it. And that's what we're seeing. So these are not counterfeit devices. They're legitimate devices that have been modified. So it's totally a different attack thing, but super, super interesting. There are lots of examples of hardware espionage within the cryptocurrency world. As you would imagine, cryptocurrency has some very interesting characters. And because there is a lot of money to be made, it's very easy to scam people in the cryptocurrency world who aren't familiar with actually how cryptocurrency works. People, it turns out, are very trusting online. If somebody reaches out to them and says, hey, do you need help? Run this program. Sure, I'll run that program. People in this room, obviously, we're not going to do that, but most people are not technically competent and miss a lot of red flags. So before I get into the actual hardware implant about ours, I figured I would sort of share the wealth across other cryptocurrency wallets as well, because I'm not just picking on Ledger, not just picking on Trezor. It's something that happens across the board. But there are some known examples of other sorts of hardware espionage that already exist. And Trezor has two devices, so different cryptocurrency wallet. Trezor 1, Trezor Model T, they use different microcontrollers, different functionality slightly, but the same style of attack where these devices were discovered sold on a Russian marketplace that they looked pretty much the same, but the code of the actual device had been compromised. So now instead of getting like a randomly generated private key or your recovery seed, the code had been modified so you're getting a pre-generated key of some, there's like 5 of them and you just get one of those pre-generated keys. So to you, as you're setting it up, it looks like it's random, but the attacker knows that you're getting one of those recovery seeds, and if they have, access to the recovery seed, which they will, then they can just steal your money whenever they want. As soon as you put money in, someone can take it out. So this was not a hardware modification. It was a hardware modification to put the new chip in, but really a firmware attack. And here's what it looks like. I've been trying to get my hands on these for a while, but it turns out it's pretty tricky to order stuff from Russian marketplaces. And I actually had somebody offer to send me one through some random connection on Discord. I'm like, I'm not sure if that's safe. So this picture on the left is a regular Trezor one, what it looks like inside, and we see this coating on it, which is just a conformal coating to protect against dust and corrosion and stuff like that. The image on the right is the modified version. So what they basically did is took off the existing chip that's on the board, which has code protection and other features, just took the whole chip off, put their own custom code on the new chip, and just soldered the new one back on. And it's nice looking soldering too. Like if you open up the device and you don't know what to look for as far as differences, like it looks pretty good. In this case, Trezor is open source, so it made the attack easier, but of course, that is not the cause of the problem. Anything is open source if you spend enough time with it. It was really because I would say it's a general purpose microcontroller, easy enough to extract code from if you need to and patch stuff, but a very clever attack. Trezor Model T, same thing. They use an STM32F4, so slightly different layout, has a touch screen, but same attack where the original's on the left, modified one's on the right. You'll see it has this like black adhesive all around it. It turns out that Trezor devices, the way they're manufactured is ultrasonic welding. So it's basically 2 pieces of plastic vibrated together to create like a 1-piece housing. When you cut through that, there's basically tamper evidence. There's visible evidence that you've opened the device. In theory, that should be good enough for somebody to say, wait a second, my device has been tampered with, I shouldn't use that device. But it turns out humans don't really pay attention to that a lot of times, especially the ones that are susceptible to being scammed. You and I will notice that and be like, no, I'm not using it. A lot of people skip, they intentionally miss the red flags of things, or maybe unintentionally miss the red flags that seem obvious to us. So the top is a known good unopened Model T. Bottom one has been opened, compromised, and put back together. They're just holding it together with tape, with that black tape that was in there, and still, did the job. So hardware implants is a subsection of hardware espionage where you're taking a known good functioning system and then adding additional hardware to it. Those other examples really were firmware modifications as opposed to tapping on to something that already exists. Probably the most common thing that we're familiar with would be like a credit card skimmer where you're using an ATM or a PIN debit card at a gas station or whatever, and there's additional hardware put on there that's capturing your magnetic stripe information or your smart card information, and then somebody steals that. There's lots of other examples. Well, I guess maybe even like game console mod chips, right? Where we're intentionally putting a hardware implant in there to bypass some sort of security or do something. Hardware implants basically are automated versions of some sort of attack that we would have already figured out. So we would reverse engineer a system. We'd figure out, okay, what security do we want to bypass? What information do we want to gather? And then we would create some sort of device to do that for us, to automate it. And potentially to mass produce it against, for a lot of different devices. Which brings us to the Ledger Nano X. And there's actually 2 things. There's a previous example, and then there's a current example. So the Ledger Nano X has a much different design than the Trezor Model T. We'll talk about that, and from the Trezor Model 1. But the original sort of attack, at least that we know of publicly, against Ledger devices was back in 2020. They had a database breach where basically their customer list was released. And that had like the product that was sold, customer names. And it's sort of like that just happened and kind of the issue was resolved, kind of went away. But a little bit later, people started receiving unsolicited packages in the mail of a device with a letter apparently written from the CEO that was like, hey, as you know, we've been hacked. Please use this new Ledger Nano X that we're sending you to make you more secure. And I don't know how many people fell for it, but I am still trying to get one of these as well, and I know people that have them. And it basically looked like tried to look like a new Ledger Nano X. One of the big giveaways really is you look at that shrink wrap, it sort of has a blue tint to it, but it's like really bad quality. You know that an actual product manufacturer is not gonna ship something like that. So just seeing that is like, obviously it's been repackaged. The letter that was written that came with this device was like, can't really see it on here, but yeah, it's like, we've been hacked, blah, blah, blah. There's some real grammar issues in here. We deeply apologize for the inconvenience. We now guarantee that this kind of breach will never happen. Signed, CEO. So really, it was like a hardware-based phishing attack. And if you think about it, it's like, this is a lot of effort where they could have just sent emails and tried to trick them. So this was kind of fascinating of like, again, we don't see this stuff in the wild very often. So when this happened was like, wow, somebody's putting in the effort. It even came with a little piece of paper where you're supposed to write down your recovery seed. And then when you plug in this new ledger, it turns out that there was an additional little USB thumb drive added in. So now when you plug in the device, it shows up as a thumb drive. You run the executable like the letter tells you to, and you enter in your recovery seed. And that doesn't set up the new device. It just sends the contents directly to bad guy, wherever they are. So basically, a hardware phishing attack to get somebody to run some malicious software to steal your recovery seed. Pretty involved. But it proved that hardware attacks can happen and that this sort of targeted attack and based on that customer database being leaked, now they had their more direct targeted audience to go after. So now we get back to the one that we talk about today, this other sort of hardware implant. So this guy had sent me one, but I wanted more devices. When you're hacking on something, it's nice to have more than one because we can actually mess around with things, break things, take stuff apart, not have to worry about it. So I wanted to see if I could still get access to some of these hardware wallets, these compromised ones. So I went to the Lazada page, and there is a legitimate Ledger reseller, like an authorized reseller. But then there's a whole bunch of companies that look like a legitimate seller, and they even say they're legitimate sellers, but they're not. So they have slightly different names, like TH Ledger, TH Ledger Nano X, TH Ledger. Things that if somebody's not looking and they're just searching for the cheapest device, they're not gonna find the authorized reseller, they're gonna find one of these other ones. So I found a couple of them which were decently priced, bought 3 of them, got 3 of them back, and now you can see like these are actually properly shrink wrapped. If you look at one of these devices, you cannot tell that they've been compromised. Like I was hoping they were compromised, but when I received them, I'm like, maybe these are just original devices. And since then, I've ordered a lot more devices, and I've gotten some from the same sellers that are not compromised. Maybe they know that I'm ordering some, or maybe they're just trying to mix things up. But it looked really, really good. It turns out that all 3 of those devices had hardware implants in them. So now I had a bunch of them that I could sort of mess around with. I don't have videos of the original unboxing, but I did have some GoPro overheads. I mean, I guess I do have video, but it wasn't that exciting. But here's a shot of it. I'm opening it. We can see the hardware implants. Here's a close-up of it. So now we can see there is the board. There's this weird like epoxy, some sort of epoxy that's holding that board down. And now that I had more than one, I could get a little more aggressive with trying to remove it. So I tried a couple different things, and it turns out that using acetone to soften that epoxy to pull it off worked the best. Pulled that off, and here there's like a bunch of additional epoxy residue on there. And then used like a spudger, like a little plastic tool to kind of poke away as much of the epoxy as I could. So here's a good view of it where we have the original Ledger Nano X board. We have all of these wires. These wires are all coated in a clear plastic, so it looks like they're all touching, but they're not short-circuiting or anything. They're like angel hair wire, just thin wires connecting with now the external battery and then that little implant. And here's a close-up of it. I didn't spend a lot of time getting all that stuff off in the center because I sort of assumed that that was some sort of wireless module because we can see the little kind of ground fence around it. And normally there'd be a metal cover on top, but the adversary took the cover off to obfuscate what it was. They scraped off part numbers, but I could see the little antenna there, and I didn't want to damage the device. So I took off enough so I could kind of see what was under there, but I wasn't going to physically go after that part anyway, but I wanted to at least see what was there. So that's the front side, and here's the back side. And this is pretty nice. If you've ever hacked hardware, it's like, wow, there's test points there, and they're even labeled for us. Like, they made it super easy. So on the left side, where it connects to the actual Ledger hardware, we see on, CS, clock, DI, ground. So some sort of interface. We'll figure out what that is. And then we see SWC, SWD at the upper left. That's an ARM serial wire debug. So that tells us right away, even without knowing the part number of the chip, that it's probably going to be ARM. DP, DM, and ground, that's going to be our USB connection. So it's like, wow, there's USB on this thing too? And then a boot pin, which I didn't know at the time what that was. I actually thought it was a boot pin related to the microcontroller, which is common, especially for STM32 microcontrollers. There's usually a boot pin, and you can change the boot, how it's booting from RAM or from user code flash or from the bootloader. That's not what it was for. So now I started reverse engineering it. I wanted to figure out how this thing was connected, what was it doing. This is the regular Ledger Nano X layout, the design. It uses a general purpose microcontroller for certain things, but nothing critical. All of the magic happens inside of the secure element. If you looked at like earlier versions of Ledger, the Ledger Nano S, they had the secure element handling the cryptography stuff, the private key storage, but then the microcontroller was handling the display and the buttons. So there was potential for somebody to modify the general purpose microcontroller to put different stuff on the screen. That was patched, that was fixed. This device, everything important is running from the secure element. The buttons, the display, everything. So there's really not a lot of kind of entry point for attacks. So it's like, well, what the heck are they doing? Are they modifying firmware? Probably not, because there's like a firmware check that happens with the Ledger software. Like, everything is sort of integrated. And so they had to come up with some other solution, which we'll get to. But there's sort of limited options, right, of like buses and things that they can connect to on here. So here's the top side. The top one is the legitimate Ledger Nano X. This one I'd actually screwed around with, so I'd taken off the secure element at one point. The bottom one is one of the devices with all of the additional stuff. And you can see from the front side, it's not just the implant that was added. There was additional circuitry added on the top side also. Some resistors in place for things. So I wanted to figure out what it was doing. And it's basically some things to just keep the system operating normally. So the front side, normally there's a battery, has battery management system, has a thermistor in it. The battery that they used did not have, the replacement battery did not have thermistor. So there's a fixed resistor that they put in place on the modified board to basically act like a thermistor. And now the system thinks it's just always at 25 degrees C or whatever, standard room temperature. And then there was also a fuel gauge sort of sensor that's just thinking the system thinks it's always full, just as a way to get this modified battery to work with the system. But what's more interesting is the stuff on the backside. There was all this epoxy on there as well. I just scraped some of that off, and we can see a bunch of different wires going to a bunch of different test points on there. So got my microscope, got my drawings, spent, I don't know, probably half an hour tracing stuff out, trying to figure out where it all goes. And it turns out that I could trace out, because I knew the part markings or I knew the markings on the silk screen from the board, I could label where they go onto our board, and those end up being, which I kind of already knew in advance, those were SPI connections. Serial Peripheral Interface, a really common interchip communication protocol, or device to device or chip to chip communication. That is, if we look back at the Ledger block diagram, the connection between the secure element and the screen. Because again, there's not a lot of external interfaces that can be looked at. So the implant is tapping onto those SPI lines. Oops. And there's a data in because the secure element is sending data to the display. So the implant is tapping onto those lines and doing something with it. We don't know what, but we know it's connected between the secure element and the screen, which is pretty cool. So then I start seeing, like, how can I interface with this implant in different ways? The first thing is I knew that was an antenna. I knew there was some sort of wireless capability, but I didn't know what it was. So I just desoldered the antenna, unrolled it, measured it. 8 centimeters, seemed to be around 900 megahertz, 937 megahertz. I figured that was just some sort of like low-cost generic RF transmitter, right? That you would see, like, that you could clone with a Flipper Zero or whatever. So I figured, okay, let's run HackRF, let's run Spectrum Analyzer, let's see if we can identify any sort of transmissions that are happening when I plug in the device. And there's nothing. Nothing changes when I plug it in. So I was like, well, that's weird. Maybe it doesn't transmit all the time, is probably one of the things. Or maybe it's not a generic RF device. Maybe it's something more complicated, but I just don't know yet. So this was my first attempt anyway of, like, let's see if there's any activity. There wasn't. So I was like, all right, what can I do next? Let's at least get a sense of what the implant is seeing. So I use a logic analyzer to connect to the same signals on the board as the implant, and then I'm using my Sele logic analyzer to see the activity. So here's, oh, did it show the, oh no, it didn't show it. Okay, so this part, I'm in the screensaver mode, so it's constantly transmitting, so I can actually see data. And then here's the view of the logic analyzer, so I can actually see the data. There's the chip select, there's the clock, there's the data being sent from the secure element to the display. And because it's in that screensaver mode, it's just sending a lot of data. So I just wanted to see, okay, this is what the implant is getting. It's getting a lot of data. Whatever it's doing, clearly, it's not transmitting all the time, so it must be doing something else. But I just wanted to visualize what was happening with that. Then I said, let's look at this USB port. So I soldered some test points to a connector, plugged it in. No, nothing. Did my LSUSB. No device was connected. And I'm like, well, that's weird. It's clearly there. Maybe it's disabled. Maybe something else has to happen. And that's when I looked at the boot pin, because I had done some reverse engineering to try to figure out where those test points went. And I'll show you that with, like, looking at the microcontroller. That boot pin did not go to the microcontroller. So I was like, all right, it's not for the microcontroller. Maybe it's for the USB. I didn't even know what that USB was for yet. But I messed around with the boot pin. I said, okay, let's pull the pin high, pull the pin low, see if that enables some sort of thing. And lo and behold, when you pull the pin high, there's basically a bootloader that gets enumerated for some amount of time. And then after 15 seconds, you see this composite device come up. And this says Air M2M. Okay. Looks like a vendor name of something. Here's what the whole little setup looked like. I use the USB Type A because I don't really like USB-C. I thought it would be easier to just solder wires to this gigantic connector that some of you have never seen before. But I have a lot of those, and that was the easiest way. So what I noticed is that composite device that showed up, it was actually 3 different virtual COM ports. So I could actually use my terminal program. You could do this with Screen or Minicom or whatever. And I opened all 3 ports. One of them I wasn't getting any data. One port, just getting these periodic sort of blocks of data coming across. And then we see the back one is just constantly sending some sort of binary data. We might not have the baud rate right. We eventually figured out that sort of diagnostic logging data. But the information on the left is what really, really was useful. Let's see if I can zoom in on it. Right, okay, so there's a bunch of, like, we can actually see some printable, ASCII text in there, and that's, like, pretty amazing. A couple things stood out to me. Remember that we didn't know what type of wireless module this was, what was happening with it, but what we see from this dump is it's showing us this EC716S. That's an actual chipset. And then we actually see a number that turns out to be an IMEI. So this is not a generic RF transmitter. This is an actual like cellular module. So this thing is connecting somewhere. We even see test SPI, like it's connecting to the SPI interface, and it's sending something over a cellular network, which is like, holy crap. And then I start getting worried of like, I'm doing this from my house. Like, does somebody know where I live now because I'm now hacking on this and it's sending something over cellular? And I told my wife, and she's like, this is like a spy novel, like so cool. I'm like, yeah, until they show up at our house. So this was, it showed the EC716. So that turns out, that's actually a chipset from a company called Eigencom, if I'm saying that right. But that was the chipset. So that's the chip inside of the module. We still wanted to figure out what was the actual module that was using that chipset. Looking up the IMEI, we actually see model name Air700E. So that's actually telling us that that's the hardware that it's registered to. It turns out there's a company called Luot out of China that makes a cellular module. It's an LTE, so it's 4G LTE, Cat 1. Basically, this thing is an IoT device, machine to machine, device to device, which is pretty rad. So I knew that it was a cellular module. I still wanted to figure out what I could about the microcontroller. No part markings on it. It was a 3 millimeter by 3 millimeter QFN20. So I said, okay, let's just take some oscilloscope measurements. Let's see where things go, continuity test, find power, find ground. We knew, the SPI lines. We could trace out where those went. We could trace out the SWD connections. And I just made markings of like other ones. And I said, how hard is it going to be for me to just search the internet and find a 3x3 QFN20 package? And we know the SWD lines are fixed. We know power ground. It turns out very hard. We have still yet to identify what the chip is. I looked at every US manufacturer. I had ChatGPT try to find non-US manufacturers, Chinese companies, anywhere where there might be like a subset of manufacturers that are not normally known. Couldn't find one. But we still knew that we had the SWD connections to look at. So maybe it doesn't matter if we know the actual part number or not. So first I wanted to verify if that SWD interface was on. Most of the time now with debug interfaces, you expect code protection. You expect something to be there of like not giving us access. So I threw the device connected up to the JTagulator, which is an open source tool that lets you sort of identify debug interfaces and UART interfaces. And I was just using it to verify those pins. You could do that with the Sager J-Link or whatever with OpenOCD. I just used the JTagulator because I designed it and I'm familiar with using it. So I ran the JTagulator, and sure enough, on the 2 pins that it told me were clock and data for SWD, it actually is, and it came up with the device ID. So the chip responded, which meant there was no code protection. But the coolest part is the device ID that it responded with is BC11477 is a generic device ID for the ARM Cortex-M0. So now, even though we don't know the part number, that doesn't even really matter. We know it's ARM. We have debug access. We can now get all the code out. So this is what my setup looked like. I was just using this device up here, the Phi Whisperer. That's like a USB protocol analyzer that Colin O'Flynn makes from UAE, or from New AE. I'm just using it to power cycle the board as I was doing kind of probing of the device. So here now I'm using OpenOCD with my Sager J-Link to connect properly to the debug interface. And we can see that we're connecting properly. Now I'm going to connect to the interactive mode for OpenOCD. I'm going to halt execution. Is that it? That might be this video. OK, so halted execution. Now it's basically the device is sitting there waiting. And then what do I do? Oh, yeah, OK. Then I'm just displaying a couple memory locations to see, like, oh, wow, I can actually access flash memory. I can see the program counter, stack pointer, all of that. Then I'm using the dump image command from OpenOCD, which is going to magically just dump all the flash. It turns out I knew it was a 32K block because I was trying to dump larger sections, and I would just get an error. So I just kept going smaller and smaller until I got to the point where it was actually dumping the data. And that way I knew it was 32K. I did the same thing with the RAM, and I think it was it was 8K of RAM. So sort of blindly discovering the capabilities of the device. So now I had the flash. Here's all the code. I usually run strings, is like the first thing I do once I get a dump, to see if there's any identifying information. There was a couple things that were related to like the compiler, I guess, but nothing that indicated what it was doing. It wasn't like, hi, we're a hardware implant, transfer contents or whatever. So I had to do a little bit more, which I'll explain. There was also a UART interface, which is on the cellular module itself. It wasn't available on test points of the board, but by looking in the documentation, and also when I was probing the microcontroller, I noticed there was a UART interface, which is a standard sort of device-to-human connection where we see some like boot information and other stuff. And it turns out there's actually two interfaces. One of them connects to the microcontroller, and that's going to be the microcontroller communicating to the cellular module, and that's how those things talk. And then there was this debug section that actually was also dumping information out. But this, I believe, was from the main connection in the bootloader state that was transmitting some information. So there's still a lot to explore of other parts of this system. Then, it turns out, now that we knew it was a cellular module, there was this 8-pin device on the board. I don't know if you remember, in the module there was the microcontroller, some 8-pin device, and the cellular modem. I thought that 8-pin device was an SPI flash, because everybody assumes 8-pin devices are SPI flash if they're near a microcontroller. I was totally wrong. I start taking measurements, comparing it to an SPI flash footprint, and I'm like, well, this doesn't make sense. Like, power's in the wrong place, ground's in the wrong place. I see data being sent, but only on power up. Like, I started questioning myself of like, is this some weird pinout of flash that I don't know? Like, I was so sure it was SPI flash. But then once we realized it was a cellular module, it's like, okay, now let's actually try to pretend it's not SPI flash. What else could it be? And it turns out that it's an eSIM, which is an embedded subscriber identity module. So it's a SIM card on a chip. Looked in the data sheet for that and said, oh, it actually matches everything that I'd been measuring. Even power and ground, I'd never seen, well, I've seen a couple chips with power and ground at the top corners, but it's not very common. But this is something called MFF2. It's an industry standard pinout and footprint for eSIMs. That's a DFN8, so 5 by 6 millimeter, still pretty small. But basically, it's a SIM card. You can use the same types of SIM card tools to experiment with it. This is a screenshot of the data that I was capturing on PowerUp. And I was like, OK, how can I do this in the quickest way? I happen to have this little microchip, old school smart card adapter that was a smart card to USB interface. And it was PCSC compliant, so you can use all the regular smart card tools with it. And then I had to figure out a way to get the eSIM adapter in, to adapt the eSIM footprint to that. So I'll show you a picture of that. And then I found a tool called PySim that lets you query SIM cards, specifically for querying SIM cards and getting information out of it. So here I am getting the eSIM off with hot air. Here's my little adapter. Here's the chip going into a little socket that I bought on eBay. And then here's the total thing. So the adapter on the front. This little extension board was from like some old satellite TV smart card hacking that I just happened to have in a box. And then I kind of built the interface around it, run the PySim tool to basically query whatever device is there. And it said, it's an eSIM. And it's actually talking to. And it's like, holy crap, this thing is really an eSIM. And it has data that we can read. So there's a whole bunch of different commands that you can do once it initializes. Here's one where you can see all of the different data that's potentially available. And then you can actually start dumping data as well. In JSON format or text format, it's dumping everything that's available from that eSIM. It's like, all right, maybe we can get some information about the adversary based on that eSIM. So looking through a bunch of the different data, we found some super interesting stuff. One of them is the IMSI, so it's the subscriber identity. We see that this SIM was originally registered in the Netherlands through Vodafone. And that's interesting. It's like this thing came from a shop in Thailand, but the eSIMs were set up or registered in the Netherlands? Is this like some global conspiracy? There's also the service provider name, and it says data only. So that shows that it's not like a voice SIM or anything like that. Data only service. So again, it confirms this IoT, like M2M, machine to machine sort of thing. And then we see a couple interesting things down at the bottom. The EPS LOCI, that was like the last connection through one, I can't remember if it's 3G or 4G or something. It's some last connection of one of the networks was in the Philippines, which is like, okay, was it registered in the Netherlands, set up in the Philippines, sold out of Thailand. And then we see the other one, USA, T-Mobile. It's like, oh crap, it really did connect to the cellular network while I was hacking on it in my house. But it's a really interesting chain of how things go. So this ultimately is what the hardware looks like: antenna, cellular modem, microcontroller, eSIM. And then one little final bit, of course, we still had to figure out what the heck this thing was doing. So threw the firmware into Ghidra, had a little bit of help with my ChatGPT friend, which is very useful for reverse engineering. Even if it's wrong, it still gives you some ideas of where to go. I ended up finding this function that is basically, there's like a whole bunch of different, if, else, whatever. It's checking kind of 26 characters. It's like, all right, that's interesting. It's like definitely a very interesting looking function that's happening there. Then I look through the rest of the dump and see at 7,000 hex, there's this little other blob of data. So something is looking for characters, it looks like, or 26 characters, A through Z. And then at 7,000 hex, this little data blob, it turns out, is actually a little storage area. And that storage area contains A through Z letters, which turn out to be the recovery seed that's stored there. It's like, all right, so kind of putting this together, it's like looking for 26 characters, putting them somewhere in memory, and it turns out that sort of this high-level functionality is this implant is monitoring the screen, the SPI communication that's being sent to the screen, when certain glyphs are being sent to the screen, the A through Z, which is when the user is configuring their device to set up the recovery seed. It's logging that, storing it into RAM. Eventually, that RAM gets moved into flash as this persistent storage of the recovery seed information. And then when that's ready to be transmitted, it gets transmitted through the cellular module to the person who is watching, essentially, the user setting up their device. And now they have their recovery seed, so whenever they want to steal all of the funds, they can steal all the funds. Pretty wild. And a very, this is way more involved even than the first hardware implant, that we saw with the thumb drive. This is really some massive amount of effort with relatively expensive devices, and they're building hardware, making a product. So maybe it's lucrative. It probably is lucrative. We don't know. There's always future work to be done. This is something, you find something like this, you kind of want to just unravel all of it. Maybe there's a way to monitor the actual cellular communications. I had learned about a project called SRS RAN, so you can set up your own 4G base station. You can use Signal SDR Pro, so maybe I can redirect the traffic to me instead of to, say, T-Mobile or anywhere else. Maybe put it in a little Faraday cage so it can't transmit somewhere else. We might need to change some of the contents of the eSIM itself, or of the cellular modem, which we haven't been able to interact with the cellular modem directly yet. And maybe learn more about the adversary. That's sort of, I'm curious about it, but that's not my motivation. I don't exist to hunt people down and blame them for what they do. Especially if you know my history, that would be very hypocritical. So I'm more fascinated from the technology side and, partly the motivation side. But of course, that's something that will probably happen is where is this coming from? What's happening? How is this whole thing sort of going? And it actually, based on some work, it looks like this web is a lot larger than we thought it was. So it's very, very fascinating. I did reach out to Ledger about this and said, hey, by the way, we found these implants. I'm going to give a talk about it. It turns out that they had also had experience with some of these. So we started collaborating, which was super cool, sharing some information about it. And they're aware of this, and they're making devices that are now hopefully, more kind of have more mitigations to prevent stuff like this. And I thought what was interesting of what somebody said over there is our design is so good that that's the only way that they could actually try to hack us is by monitoring this external SPI interface. Not going directly after the secure element, which maybe will happen at some point. But the hardware design is designed as you would try to design a secure device. So it was interesting of the adversary just looking for whatever way in that they could. So they have some recommendations, and they actually have some pictures of known good hardware, so now somebody can buy their device, and they should compare it to make sure it hadn't been modified, especially somebody who's not familiar with implants like we are. Some best practices, buy, of course, from authorized resellers. That's the number one thing always. I get emails from people all the time, and they're like, I bought this thing from wherever. It's not hard to find the legitimate people. It was cool, though, that this guy bought it from the cheapest possible place and sort of discovered this whole thing, which is neat. And then they're also doing some further hardening of like some single-piece unibody devices to prevent this. But cryptocurrency hardware wallets for sure are always going to be a target. Hardware espionage is always going to be a thing. But it definitely is fascinating to me that it's hitting sort of this consumer world. And it's not just like government against government. So yes, that's it. There are actually new iterations of the implant. And that's how we're starting to see like, wow, they're being shipped from different places. There's modifications to it, just like, it's a cat and mouse game. Just like we as attackers find a problem, it gets fixed, something else happens. The implants have gotten much better, much nicer looking, much more integrated. And that's a whole other, fascinating story. But yeah, so, thank you for coming and listening and watching, and maybe you will get inspired to get some of these devices and explore them, or open your hardware now and see what else is in there. But yes, so thank you again.